Okay, welcome back, algebra students. Mr. Zacek here. We're going to do, today we're going to talk about counting principle and tree diagrams. And this is something that's a pretty straightforward concept, but, is often asked on um, our Regents exam. So we'll just go through it here. In the first one, we're going to talk about a tree diagram. Now, when you see the word tree diagram, a tree diagram is going to have branches. That's where the word tree comes from. And a sample space is going to be a list. So just as we recognize what those words mean, tree diagram, we're going to have branches, sample space, list. So in a math class, there are 4 students in the first row, 3 boys, Chad, Robert, and Jake, and 1 girl, Ashley. The teacher will call on one of these students to the board to solve a problem. When the problem is solved, then the teacher will call upon one of the remaining students in the first row to do the second problem. Draw a tree diagram and list the sample space. All right, so what I'm going to do for my diagram here is I'm just going to make a key first. I'm going to say let's let Chad be C, let's let Robert be R, let's let Jake be J. Let's let Ashley be A. Okay. So the first teacher, she's going to call on one of them. So the first student could be either Chad, Robert, Jake, or Ashley. And then for our tree diagram, we're going to branch off of that. And so each one of these is going to have 3 options. So if she called Chad first, she could then call Robert, Jake, or Ashley. She called Robert first. There's going to be 3 people left, Chad, Jake, or Ashley. She called Jake first. She could call Chad, Robert, or Ashley. If she called Ashley, should have given myself a little more space. She could call Chad, Robert, or Jake. Okay, that's your tree diagram. Now, the sample space is just a list of those options. So if you follow the path, if we start here at the first one, it was Chad and Robert. So it could be Chad and Robert. It could be Chad and Jake. It could be Chad and Ashley. It could be Robert, following the R goes to C, Robert and Chad, Robert and Jake, Robert and Ashley. Could be Jake and Chad. It could be Jake, J goes to R, Jake and Robert. Could be Jake and Ashley. And then our last bunch on the trees, it could be Ashley and Chad, it could be Ashley and Robert, and it could be Ashley and Jake. Whoop, looks like I put an extra comma there. Okay, Jake and Ashley. So you usually are going to be asked to draw one or the other. Sometimes you could draw both, but so we see we've got the tree diagram and the sample space. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 options that she has here. So now find the probability that Ashley will be one of the 2 students called in the board. So in this case, for A, now probability, that means how many times is Ashley's name called over the total. So I go to my sample space. I've got Chad and Ashley, Robert and Ashley, Jake and Ashley, and then all of these ones in the last one have Ashley. So I see 1, 2, 3, 4, 5, 6. So 6 out of 12 would be the probability because there's 12 possible options, which would equal, you could reduce it to 1/2. What's the probability that at least one boy will be called? Well, okay, Chad and Robert, Chad and Jake, Chad and Ashley all have a boy. Robert all has a boy. All the ones with Robert. All the ones with Jake all have a boy. All the ones with Ashley have a boy. So that means out of the 12 options, everyone has at least one boy, and that means the probability is 1. So it will, in that case, when the probability is 1, it will always happen. All right. Okay, how about Ashley and Chad will be the two students called? Well, let's see. Ashley and Chad happen here, and Ashley and Chad happen there. So that's going to be 2 out of 12, which reduces to 1 out of 6. Two girls will be called. Well, we don't have two girls, so that's 0 out of 12, which probability of 0, which means it will not happen. They don't have two girls sitting in the front row. Okay, so when you have a probability of 1, it always happens. A probability of 0, it never happens. All right, so let's try this one here now. Michael is making a sandwich. He has 3 choices of bread to choose from: white, wheat, or potato bread. He has 4 choices of meat: ham, turkey, roast beef, or salami. He has 2 choices of cheese: American or provolone. Create a tree diagram to list the sample space of all the possible combinations that Michael could make for his sandwich. Okay, now I drew the tree diagram one way. I'm just going to draw it a different way now. Here we have, in our first option, we have your bread. You could have white. I'm going to leave a good bit of space here. And we have wheat as an option, or we could have potato. I think there's an E on potato, but I'm not sure. Bread. All right, now, off of those, he has 4 choices of meat. So each one of these is going to have 4 branches off of it. I'm going to abbreviate here. He could have ham, turkey, roast beef, salami. Ham, turkey, roast beef, salami. Ham, turkey, roast beef, salami. Okay? And off of that, 2 choices of cheese. So each one of those is now going to have 2 options off each one of those. So you see why we kind of space these out here. So it could be American or provolone, American, provolone, American, provolone, American, or provolone. You get the picture. I'm not going to keep saying it, but we'll just write them in. Okay. Starting to get a lot of options. Okay. So create a tree diagram to list the sample space for all possible combinations. All right, so that's your tree diagram. All right, now your sample space is going to be, here you could have, you're going to follow every pathway on here. So let me get a highlighter here just to make sure that you can see what I mean. So from white, ham, American, that's one pathway. Okay, but you could go white, ham, and then provolone. I don't like how that, white and ham, and then to provolone. So those are both 2 different options. All right, so when you're listing your sample space, you want to list all of those. So you could have white, ham, American, white, ham, provolone, white, turkey, American, white, turkey, provolone. And again, go through, list all of them, and you will see what happens with that. Okay, now this kind of leads us into our counting principle. And the counting principle says if one activity can occur m ways, and following this, the second activity can occur n ways, then you multiply those together in the order given to find the total number of possible options. So a coin is tossed 3 times. How many outcomes are there? Well, the first time you toss the coin, it could be heads or tails. That's 2 possible outcomes. The second time, it could be heads or tails. That's 2 possible outcomes. The third time, it could be heads or tails, 2 possible outcomes. So you just multiply those together. You get 8 possible outcomes. Now, what we had done earlier, if you wanted to find out what those outcomes are, your first toss, heads or tails. Your second toss, heads or tails. Your third toss, heads or tails, heads or tails, heads or tails, heads or tails. Okay, so what you're going to find is that 8 possible outcomes is the 8 branches of your tree diagram. Okay, so we don't always have to do the tree diagram, though. We can sometimes just use the counting principle. So each morning I try to find a different outfit to wear. I have 27 shirts, 5 pairs of pants, and 6 pairs of shoes. How many different outfits do I have consisting of 1 shirt, 1 pair of pants, and 1 pair of shoes? So we got to get a shirt, we got to get a pair of pants, and we have to get shoes. So our first option, we have 27. Our second option, we have 5. And our third option, we have 6. And we're going to multiply all of those together. And so we do 27 times 5 times 6. All right, which I'm just pulling up a calculator quick to do. Okay, it's going to be 30 times 27. And we get 810. Okay, outfits, possible outfits. Okay, so let's try another one here. Number 3. All right. At the movie theater, there are 10 choices: Dr. Seuss, The Lorax, The Hunger Games, Wrath of the Titans, The Three Stooges, The Lucky One, Think Like a Man, Chimpanzee, The Pirates, Band of Misfits, The Avengers, and 21 Jump Street. In the area, there are a few restaurants: Outback Steakhouse, 99, and Uno's. So we've got 3 restaurants. If I go to see a movie and then go to dinner, how many ways can I spend my evening? So your first option is movie, then you're going to have dinner. Well, we got 10 movie possibilities, you got 3 dinner possibilities, you got 30 ways that you could spend your evening. So you're just multiplying them together. So the counting principle is pretty straightforward. We'll just do, I want to do number 6 here because this one is happens a lot. A state issues license plates consisting of letters and numbers. There are 26 letters, and the letters may be represented on a plate. There are 10 digits, and the digits may be repeated. Tell how many possible license plates. Okay, so the key here is the digits may be repeated, and you want to know that there's 10 digits and 26 letters. The reason there are 10 digits is because 0 counts as a digit. So the digits, just so you can understand that, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we count 0 as a digit, which is why there are 10. Okay, now, so there are 26 letters. The letters may be repeated. Okay, that's also important. So 3 letters followed by 4 numbers. 2, 3, 4. Number, 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 number. So you have 26 possibilities, 26 possibilities, 26 possibilities, 10 here, 10 here, 10 here, and 10 here. Okay? So you just want to go ahead and multiply those together. So we do 26 times 26 times 26 times 10 times 10 times 10 times 10, and you get 175,760,000. Okay, that's why New York State isn't going to run out of license plate options. Okay, for a while. 2 numbers followed by 4 letters. Okay, so we got number, number, letter, 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 letter. So you could be 10, 10, 26, 26, 26, 26. So when you multiply those together, come out with 45,697,600 possible options. Okay. So hopefully you're seeing how the counting principle works. I think that we'll do a little bit more about that, and we'll talk in the future about what happens when it's not repeated. So what you would have in this case, if it wasn't repeated, it would be 26, 25, 24, because you would have one less option there. All right, so tree diagrams and the counting principle. Um, so please ask any questions if you have on those in class. All right, goodbye.